let's get started. So I'm Daniel. I'm the lead architect for Spectrum Fusion for the German-speaking area, so Germany, Austria, and Switzerland. So we want to talk about day two operations. Day two operations are, for example, if you plan to move into a house, day one operations is building and planning the house, moving into the house and deploying your furniture and everything. And day two operations afterwards, living in the house. So in IT terms, it's monitoring, it's troubleshooting, it's updating the software stack, it's everything you do during normal operations until the thing gets decommissioned again. This is what we refer to as day two operations. We as the IBMers always focus on things like Spectrum Fusion is fully container native and it runs on top of OpenShift, right? We don't need any hardware appliance next to it who monitors the stack. We don't have any bastion hosts. So Spectrum Fusion is fully running on top of OpenShift. And the important point here is that we store all our configurations of Spectrum Fusion in the etcd of the OpenShift cluster in custom resource definitions. This is very important. You will see why, because this makes the information of Spectrum Fusion available on the command line. We come to that in a second. This is stuff we always highlight and pitch and present as our unique values. And on the business side, the business teams often say, yeah, it's nice that your software runs, but I want to backup software to containers. Why do I care if that runs in a VM or if that runs in a container? The DevOps people and the admins of an OpenShift cluster, they really see the difference, and we have to make sure they are on the table and understand what's the benefit of operating our stack and why it is easier to operate than other stacks. This is the architecture diagram of Spectrum Fusion. And yes, what we also pitch is that we have a single pane of glass, which is a very cool user interface where you get the information of the whole stack. You get the information of the storage, of the backup tool, of OpenShift. You get all the details about what's going on with your infrastructure on one single pane of glass. And that's a good advantage. But on the other side, if you look at our customers and they run, for example, 10,000 Linux systems, they don't have a UI on all these 10,000 Linux systems, right? And it's the same with OpenShift. They like to administrate their OpenShift clusters often from the command line. So with Spectrum Fusion, once you log into the OpenShift command line, you get all the information you get via the Spectrum Fusion UI, also on the command line, if you know how. Of course, this requires some experience, but this is possible. And it is possible because, for example, our backup tool has all the configuration. So what backup policies do we have? What backup locations do we have? Our schedule, all that is not stored inside the container in a proprietary format. It's stored in the etcd in custom resource definitions. And in the next slides, I show you how you get this information out of the system on the command line. And then it will become clear why it's easy to administrate the system. Before that, let's have a brief look at the user interface in case you have not seen it in close detail. The infrastructure dashboard is something that is only available on the HCI. And in this session, I will focus on the HCI because there we have a lot more advantages than on Spectrum Fusion SDS in regarding to the infrastructure management. On this dashboard, you see the compute operator status. On this small, I can show that many details. And if you press the arrow, you can dive deeper and see more details. But you see, in general, the hardware is healthy. And the same with the storage, the same with the network, the OpenShift layers. You get one overview panel and you see immediately if something goes wrong. And the same here with the events tab. But these events here can also be shown, of course, on the command line. So in case you are not logged in to the UI and you don't want to jump and open a browser, but you are on the command line, you can do an OC get events. While you're on the command line managing your workloads and your containers, you can also get the Fusion stuff here. And OC get events from the Spectrum Fusion namespace shows you what's going on and what errors you have. So in this case, we had an event from one of our high-speed switches, and the Cumulus OS is running on our high-speed switches, and there was a link down. So this is not reported from a worker node perspective. This is really reported from the switch. And you see what is down, which port is down, from which switch with which MAC address. So this is example. Oh, this is a management switch. And this error message you see here You can then go on the IBM documentation. For example, if I jump back here, you see, okay, here's all the error codes from network error codes in our documentation. And you go to the one which you have seen and you see details about it. And that works, of course, with all errors. So that was just one example. And this is more to illustrate you the benefit. So keep in mind, this is maybe not the best example, but this is what I've just seen on our Fusion in Frankfurt. And so I use it to highlight it to you. So it gets more interesting if we dive into that network portion, if you do an OC get switches. So these are the 4 switches we have on our HCI, 2 management 1 gigabit Ethernet switches and 2 high-speed switches. And if you go into the details of one of these high-speed switches, you get a lot of details. And I needed to cut this output, of course, short, or it wouldn't put on a PowerPoint slide. But what you see here is you get the port status, and you also get all the packets. And this port 32, which I've shown before, was in an admin shutdown state. But you also get information about the firmware version running on here, on the temperature, on the fan status. So you get all the information which you would normally only get from the switch operating system. So you need to be a network admin, do an SSH on the switch CLI, and then do some magic commands on the switch to get this input. Or maybe the switch has a HTTP UI. But you need to go on the switch normally to get this information. On Spectrum Fusion HCI, you have it right on the command line. In Spectrum Fusion HCI, you can define your custom VLANs, which you want to have to separate your OpenShift traffic into VLANs. And these VLANs you can also get here on the command line from the rec VLANs. So yes, we have some internal storage VLANs, which come by default. This is where the Spectrum Scale ECE traffic runs in. But you can also see the details of your VLANs right here. So all the network configuration. One important part of Spectrum Fusion is the data protection part. We all know there's Spectrum Protect Plus running in containers on top of OpenShift, and this is the backup piece of Spectrum Fusion. If you want to see what backup policies we have defined, then you can do an OC backup policies, and everybody who was ever on a Linux system knows this looks like cron output. So this is how we do the scheduling. This is the provider. And here you see what policies you have defined. On the other side, these policies point on backup storage locations. So here are your object stores, and you can see the face if they are online or not. And the important piece is you want to know if all your backups went through last night. So you do an OC get Fusion backup, and you get all the backup jobs that run. And of course, you can grep -v completed, only see the failed ones, get details about your backup jobs without logging into the UI. So that is just one piece of the daily work of an admin, checking for backups, checking for the health of the system. Very important as well when we talk about the life cycle, about the updates. With Spectrum Fusion HCI, IBM is giving you one firmware update package. So we test the whole stack in the lab, make sure everything fits to the OpenShift version, fits to the CoreOS, fits to the hardware we have in place, and then we build one Spectrum Fusion firmware package, which is called like the Spectrum Fusion version. So this was 2.10 at the time. The next one is 2.30. And if you want to get the details about that, you get all the details about what BIOS version we have, what NVMe disk drive firmware we have, what power supply firmware even. Now, if you have been into the performance troubleshooting and you have been dealing with NVMe drives from different vendors, you know that the disk drive firmware can be of importance. So if you want to know what it is and if you want to look behind the curtain, it's not hidden. We give you that information. Same with the Mellanox cards, Connect X6 and Connect X4 cards we have in the system. These drivers can have performance impacts. They can have bugs. And if you want to know what's on your Spectrum Fusion HCI, it's not hidden. You can see it here. We do give this very openly out because it's important for our updates. So we have an update manager, which is an OpenShift operator that's dealing with the updates of the whole stack. If you do get into the details of the update manager, you see not only the firmware version, right? There's the Fusion software state, which is the Fusion operator. There is the node state. So for each and every node, you see what firmware version has each node. You see the OpenShift version. Here's the Spectrum Scale version installed, the Spectrum Protect Plus version installed. and you see if there's an update available or not. So this is just the YAML output from what we show you in the UI. If you want to dive deeper, there's often more information on the YAML version than we can display on the UI. So these are the benefits. If you're an OpenShift admin, you have many OpenShift clusters, you maybe have more than one Fusion, and you want to see what's going on the command line without jumping over the UI, that's easy, and that gives you all these details. If we talk about the software stack update, let's dive a bit deeper on here. For comparison, I made 3 slides comparing a Fusion HCI software update compared to an OpenShift update on a hypervisor-based system, maybe VMware, and an OpenShift if you build it on your own bare metal, because OpenShift bare metal is of course not only available with Spectrum Fusion HCI, you can also build your own OpenShift cluster on bare metal. And the next version of Spectrum Fusion SDS will support Spectrum Fusion SDS on bare metal if you build it by yourself. So this is also a valid option. So let's dive a bit deeper into these 3 options. If you look at the Spectrum Fusion HCI, you have our operators on top of OpenShift here, and from these operators, you can update the firmware of the network switches, the firmware of the servers. You can trigger the update of core as in Red Hat OpenShift, and you update the Spectrum Fusion parts of the storage and the backup, and you have one package provided by IBM, giving you a supported and interoperable version of all these software, supported by one vendor, supported by IBM, and the package comes from one vendor. So this is the advantage of Spectrum Fusion, right? One tested stack that is really the interoperability between the CSI driver of Red Hat OpenShift works with our storage Spectrum scale, and all that is one package. So that makes life easier. If you compare this to a stack that is on VMware, for example, you see the layer becomes a little bit thicker because you have the hypervisor up here. If you don't have the Spectrum Fusion storage, you also need to take care, maybe you have a different backup tool. If that tool works together with the storage and works together with OpenShift, is something you need to check out by yourself. And the storage can be container native, things like ODF, but it could also be a CSI driver that accesses an external storage system, could be from a different vendor like NetApp. And here you also need to check the interoperability of your storage CSI driver, if it works with your backup tool, if it works with OpenShift. And then down the stack, from Red Hat OpenShift, you can only see the hardware of the VM, because the hypervisor gives you a virtual piece of hardware, so you cannot see any of the hardware information from your switches, from your servers. If the net power supply is faulty or anything, details of the network, you cannot see because your Red Hat OpenShift live in this virtualized environment. And this hypervisor need to be taken care of by somebody. If we look at the people involved in updating this network stack, I was working in a big company, in a big shop. So this is more or less the team setup we had in my old employer. And we had a dedicated hypervisor team. These guys were only taking care of the ESX servers in the company, and they were patching and managing the hypervisor. And the OpenShift DevOps teams were customers of the hypervisor team. So the DevOps people were taking part of the OpenShift stack. The hypervisor team was taking care of the VMware stack. And then there was a network team dealing with the network stuff, the top of rack switches and so on. And of course, we had a team taking care of the SAN, of the storage area network and everything around it. So the CSI part here, depending highly on the setup you see at the customer side, but this might be the 4th team dealing with it. So if you want to update the whole stack, you have a lot of things to check. Bare metal, like I said, is not only available by us, you can also build it yourself. And then you might have the people who install you the server and the infrastructure. So updating the firmware of the server is crucial to pass audits like the PCI DSS audit and others, because the server has here an API, it has here a web front end on its management processor. So the server firmware need to be updated once a year at least. The question is, who is dealing with these updates of the server firmware and of the network switches? Because these parts of the stack should be updated as well. Yes, the DevOps team can then deal with the stack above. If it's bare metal, there's only CoreOS running on the metal, there's OpenShift. And then you have your storage part. Here I intentionally put in Spectrum Fusion because that makes things also easier here from the storage and backup perspective. But of course, you could also have the yellow boxes there with external storage. Of course, that works as well. So bare metal, yes, is the slimmer stack. But if you build it yourself, your OpenShift cluster won't see all the information of the server underneath, like in Spectrum Fusion HCI, because this operator that we have in Spectrum Fusion HCI that is monitoring the switches, that is monitoring the servers, doesn't come with Spectrum Fusion SDS. Keep that in mind. We can do this for the HCI because we know what servers we have, we know what hardware we have, and our operators get the details out of the hardware only on Spectrum Fusion HCI. If you have Spectrum Fusion SDS on a bare metal stack built by yourself, you need to take care of hardware monitoring somewhere else. So for example, you manage the status of your power supplies and of your internal disks in these servers with third-party software. Firmware updates, of course, the same. It's not so easy because you need to get this firmware update from a different server vendor, and you need to see where you get the Mellanox drivers from, if that's provided by your server vendor, or what kind of network cards you have. So firmware updates of all this hardware which is in that server is then managed by yourself and not by Spectrum Fusion anymore. So the Spectrum Fusion HCI upgrade procedure is split into 4 pieces. And especially some business partners always squeeze me in, can you show me the full software life cycle? So these 4 steps to update the Spectrum Fusion HCI. First, you update the management software, which is the Spectrum Fusion operator. Then you update the services that come with Spectrum Fusion. So this is Spectrum Protect Plus and Spectrum Scale. And then you update the firmware if we deliver a new firmware package, like we do with Spectrum Fusion 2.3, for example. You update the firmware of the switches and of the nodes. And then you update the OpenShift Container Platform. And this update operator delivered by Red Hat to update the OpenShift Container Platform is done so well that it doesn't make any sense for us from Spectrum Fusion to write a wrapper around this operator. So this is done natively in OpenShift. First of all, you jump to the OpenShift UI and you check for installed operators, and you see here's the Spectrum Fusion UI operator. And you click on here, there's the installed operator. And if you click on subscriptions, you see what update channel you are on. And this one can be switched to automatic, then it automatically updates the operator, but I would, for the beginning, recommend to have this as manual. There's an upgrade available for you. You're currently running 2.2.1. And there's an update available which you need to grant permission to get it installed. So you click on that upgrade button. And the cool thing in OpenShift with this operator lifecycle management is you get an install plan. So you can really dive into all details if you want to. And here it says it requires approval. The next version is Fusion 2.3, but it requires approval. So you check this install plan. And that is all OpenShift magic so far, by the way. You see all your details, the small scroll bar here, so you can scroll down all the way, see all the details, what we do in install. And you approve this install plan, and then the Spectrum Fusion operator is updated. So far, it's not really critical. If you have a problem in here, your cluster will function correctly and will still operate, right? We just update our operator in that piece. So once the operator is updated, also the Spectrum Fusion UI is updated. So if you log into the Spectrum Fusion UI, you might get a bit of a new look and feel, like with Spectrum Fusion 2.3. We changed a bit of the look and feel in here. And this is the new panel of Spectrum Fusion 2.3. But you still have your infrastructure dashboard here. And you click on the services. And from the services panel, you see you have Spectrum Scale 5.1.3.1 running, and you have Spectrum Protect Plus 10.1.10 running. And that's good, but both have an upgrade available. So you decide when to do which one. And you click on the 3 little dots and click upgrade, and then comes the upgrade dialog. Do you want to go ahead? Here's the versions. This action will approximately take 30 minutes. Click upgrade, and then you get some details. And unfortunately, I don't have a good screenshot of the details and the logs of each operator, but then you update SPP and scale one after each other. Next step is, once this is done, jump to the firmware version and the firmware upgrades. So in the infrastructure dashboard under nodes, you see all the details of your HCI nodes. And if a firmware upgrade is available, you see it here. So some of the nodes in this HCI have already the new version 2.3, but some nodes are still down level. You can have for some time different versions on the nodes. The reason is you don't need to do all nodes at once. They are done anyway in secrets one after each other, but you can build groups of updates. So you put a check mark here on the ones which you want to update, and then update these ones. Of course, they're done in sequence, and then you can wait for the next maintenance windows. So one of these upgrades takes about 1 hour. If you just want to do 2 in this week's maintenance window and then 2 in the next week, there's no problem with that. So you select the nodes you want to update, click on the update button, and here's the warning. During this upgrade, nodes will be placed in maintenance mode, updated and rebooted one at a time. And if they don't come up, of course, we stop the update. This is also OpenShift magic. We drain the node, we move the workloads off, we move all pods and VMs off the worker nodes. Once the draining is successful, then the node is rebooted and the updates are installed. Here I have a screenshot of upgrade is in process. On the operators which are performing these updates, you get all kind of details on what it's currently doing. And then, last but not least, it's the OpenShift update. And like I said, it doesn't make much sense to write a wrapper around the already perfect update procedure. So the good thing is we have checked all the interoperabilities before, and we know the OpenShift version we are going to works with our storage, works with our backup tool. You see, most of the time there's an update available. If you click in the cluster settings, you can pick the version you want to go to. So you could update from 4.8.19 to 4.8.48, but that's where you stay in the OpenShift 4.8 channel. But with Spectrum Fusion 2.3, we support another version. So you need to change the channel. So you click on the channel and say, I want to go to 4.9. And then, of course, you have the fast pass, you have the candidate, you have the extended update support. With Spectrum Fusion HCI, please stay in the stable channel. As it's production, that's recommended from Red Hat and us. You select the 4.9 channel, and then it says, okay, let's go from 4.8.19 to 4.9.47. You click update. And then it lets you down select really which version you want to have of OpenShift. And once you select it, you get all the details. So first, all the cluster operators are updated, and you see how this progress bar proceeds. Then the master nodes are updated and power cycled one after each other. And then the worker nodes are updated. Done that OpenShift stuff. I think it's very well done. Yes, if you have purchased the OpenShift licenses from IBM, you also get IBM support for this update portion. And afterwards, you see, okay, you had OpenShift 4.9.47, there's no update available. And if you click on the little question mark on top, you see that which Kubernetes version is underneath and all the details. What happens when an upgrade fails? I've talked to many customers and business partners yet about the updates. OpenShift update might get stuck for one or the other reason, but the cluster always stays functional because there's one node at a time taken down and rebooted, and if it doesn't come up or if the upgrade procedure gets stuck, then you might have one operator of OpenShift impacted, you might have one node impacted. But in theory, that you have a full cluster outage and the whole OpenShift stops working because of an upgrade is something I've not heard of or is very rarely seen. So also, if we update Spectrum Scale, we do one worker node, one pod at a time. And if that one doesn't come up anymore, the pod disruption budget is exhausted. And we don't start another pod updating unless that one comes back from its update. So OpenShift itself is very stable in the update procedure. And yes, you might get stuck and then you need to get the logs of that pod, or you go to the Fusion command line and you start collecting a backup package for IBM support, and you upload all your logs, right? And then your cluster might be in a frozen state, so to say, but that everything stops working and you have a complete outage because of an update is something you will very rarely see with OpenShift, I think. We can make the customer's life a lot easier with the interoperability of things. There's one software stack that we tested thoughtfully and we deliver it from one vendor and you get support from one vendor. But all of the update procedures, this is the OpenShift magic. So the operator lifecycle, is OpenShift standard and the updates are as well OpenShift standard. So we deliver bare metal OpenShift cluster, and that is not restricted or changed by IBM. So the update procedure of OpenShift stays with the Red Hat magic, but we try to make it a lot easier by delivering software packages that have been tested before and are working with each other. This is the magic. That's it as far as the updates and software lifecycle is done.